Hello everyone. I'm Andy from ThinkMo. I'm currently teaching the CCIE course. As of today, I'm going to share with you related technologies with CCNA, CCNPAN, CCI. Our topic today is IPv4. What does it take to deploy IPv6? So IPv4 everybody knows. That's where we are now. Type of the protocol being used. IPv6 is the next generation protocol for the Internet. In the previous video, we've talked about IPv4 and IPv6. So today we are going to talk about it from three aspects. The first is why deploy IPv6. The second is how do you transition to IPv6. The third is what the transition technologies are for IPv6. So first of all, let's talk about that. Why the transition to IPv6? In other words, what are the advantages of IPv6? The first is that it has a huge address space. Its address space is 128 bits. The second is the compact message structure. The basic IPv6 header has only 8 fields. Fixed 40 bytes. The fewer the fields, the higher the transmission efficiency. The memory resources used are smaller. It can then be configured and readdressed automatically. First, automatic configuration can be implemented. Plug-and-play functionality. What is plug-and-play? The host is directly connected to the network. You do not need to configure an IP address. You don't need DHCP. I can get an address. We can reprogram it so we can look at it. Let's say two devices are transmitting data. We need to change the address. In an IPv4 environment, this is difficult. Services may be interrupted. And the reorchestration capability in IPv6. That solves the problem pretty well. Then there is support for hierarchical network addressing. Same as IPv4. Things like subnets and hypernets. It's essentially an address to the network. Let IPv4 or IPv6 address. There are hierarchical concepts. The next step is to support end-to-end security. This is one of the more important points in IPv6. It means IPv6 network. Native security features. Unlike IPv4. Combine it with other technologies. The purpose is the so-called security. What is this mainly about? For example, in IPsec. Better support for this QoS. Inside the basic masthead, there is a traffic class. A field that represents the priority is to do the stream category. The blow table was also added. It's called a stream tag. It can better distinguish between data streams. Speed up forwarding. The stream label can be on the original end. Label the data stream directly. Let's say you want to send all kinds of data. Video and voice. There's some other data on the internet. So it's much easier to divide these devices in the middle. You don't have to do triage. The efficiency of forwarding is accelerated. Finally, support for mobile features. It is primarily a technology that supports mobile IPv6. This was in the previous video. The introduction has been made. Now let's talk about the second aspect. How do I transition to IPv6? IPv6 is actually more than a decade old. It's already out there. It was about the 90s. IPv6 is already on the table. But at this stage we find that most still use IPv4 networks. IPv6 has clearly increased in recent years. But it's not obvious yet. So the main reason, right? Mostly, why this thing? IPv4 prevailed for a long time. A lot of equipment today both support only IPv4. May not support IPv6 very well yet. In addition, the length of the IPv6 address is long and difficult to remember. And then it's hard to deploy. Like a lot of devices from carriers. It is primarily a device that supports IPv4. If you want to achieve a large area of transition, switching to IPv6. First, on the cost side, there are certain considerations. Beyond that is the deployment of IPv6. At this stage, there aren't a lot of app features. IPv6 is definitely required to do this. If you make the transition to IPv6 now, is more troublesome. So we want a slow transition. On IPv4 and IPv6 networks, both exist in the case. Slowly replace to IPv6. The process of transition can be roughly divided into metaphase and anaphase. Earlier, IPv6 and IPv4 should be used together. When used together, there are some techniques involved in double stack. In the medium term, it involves compatibility between IPv6 and IPv4 networks. What do you mean by compatible? IPv4 networks. IPv6 networks can be accessed. IPv6 networks can also access IPv4 networks. Later, it may be just using IPv6. Technologies like NAT64. There are IPv4 networks. In this case, the NAT technology can be adopted. Gradually, it moved to IPv6. How does this transition happen? It certainly won't be a complete transition all at once. And finally, the third question. What are the transition technologies for IPv6? Let's look at it briefly. IPv4 and IPv6 coexist. An interworking technology. The coexistence technique is like what we call a double stack, or a 6-to-4 tunnel. It should be an IPv6 over IPv4 tunnel. It is divided into manual tunnel and automatic tunnel. Let's take a look at it briefly. Manual tunnels are classified into GRE tunnels and 6-to-4 manual tunnel. Automatic tunnels are divided into 6-to-4 tunnels and isotap tunnel. And then the interworking technology. The interworking technology is NAT64. It's IPv4 to IPv6. IPv6 conversion to IPv4. So what we're going to do? A brief introduction to dual stack technology. It's in coexistence technology. Dual stack technology has both IPv6 and IPv4. It means all the equipment. Both must support IPv4 and IPv6. It's IPv4 running IPv4. IPv6 runs IPv6. Make a strict distinction. But on the same line. Run both IPv4 and IPv6. This is the so-called double stack technique. The following is a 6/4 tunnel. IPv6 over IPv4 to be exact. It is to send IPv6 packets encapsulated in an IPv4 tunnel and then transmit it. Let's say there are two companies. Company A is an IPv6 network. Company B is also an IPv6 network. And in the middle, such as the public network operator or the Internet. The middle segment is the IPv4 network. Like today's carriers. What they're offering us is basically, this is the IPv4 network. So we have to make two companies. Between Company A and Company B. IPv6 network communication is normal procedure. We can be based on the Internet. The Internet uses IPv4 as a tunnel. And then Company A is IPv6. I send IPv6 packets encapsulated in IPv4. The purpose is to be able to connect to the public network or over the Internet. Send IPv6 packets from one end to the other. It goes from Company A to Company B. After B company receives it, then it is unsealed. That's how it works. Send IPv6 packets. Make an analysis. So 6/4 tunnels. There are several types: manual and automatic tunnels. Let's talk about the difference. So we're not going to go into the rest of this too much. There is not much difference between a manual tunnel and an automatic tunnel. They all belong to use. IPv6 packets are transmitted through the IPv4 tunnel. The biggest difference between them: you need to specify a manual tunnel by yourself. Indicates the destination IPv4 tunnel address. Automatic tunnels do not need to be configured. Of course, this configuration of the students should be more clear. So let's talk about this. NAT is the late interworking technology. Like NAT64. That is, a network that may have IPv4 on one side. On one side is the IPv6 network. The IPv4 network and the IPv6 network should be interconnected. This is where we might get there. NAT translation. IPv4 network source address destination address. Converted to an IPv6 source or destination address. On the IPv6 side, the packet is returned. The process of returning the packet. It also takes the source and destination addresses of IPv6, translated into the corresponding IPv4 source and destination addresses. That means in the middle. Have a middleman. It's like having a matchmaker. Both IPv4 and IPv6 are supported. In other words, this device. We call it a dual stack router. Both IPv4 and IPv6 are supported. If you look at the IPv4 network, there is an IPv4 address. That must correspond to an IPv6 address. The same is true in IPv6. I has an IPv6 address. It must correspond to an IPv4 address. This is how it implements the correspondence. Note that in NAT64, when you do the conversion, for example, IPv4 in order to enable IPv6 complete recognition, when you do the conversion, you need to switch sources and destinations. Convert IPv4 to IPv6. Example: convert IPv6 to IPv4. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.